Hello, everyone. Hello, hello, hello. My name is Jehron Petty, and I'm going to be your moderator for today. I'm the founder and CEO of ColorStack, where we're cultivating the largest national community of Black, Latinx, and Native American CS students. I recently graduated this past May from Cornell with a degree in computer science. In my free time, I enjoy playing video games as a Twitch streamer. But today isn't about me. It is my great pleasure and honor to host our fireside chat with two wonderful people. First, we have Angelica Willis, who is a computer vision researcher at Google AI Health, and she's passionate about pushing the boundaries of interdisciplinary applications of artificial intelligence. She's an advocate for computer science education and diversity in STEM, and was recognized by President Obama as a 2016 White House Champion of Change for Computer Science Education. And we also have Jeff Dean, a Google Senior Fellow who leads Google Research. His work has been integral to many generations of Google's search engine, its initial ad serving system, the TensorFlow open source machine learning system, as well as many libraries and developer tools. Please join me in welcoming them.
Thank you. Great to be here.
Cool. So let's start a little bit off topic here. So I'm going to ask you both 5 questions that will help us all remember that although we're listening to two legends in the industry, you guys are still human. So the way this will go is a lightning style, back and forth. Both of you will answer each question. So the first question is, what's your favorite non-work thing to do? We could start with Angelica.
Great. Yeah. I love interior decorating. Yep.
Cool.
Pre-pandemic, I love playing soccer. So I play in 2 soccer leagues. I'm clinging on in the 25 and over division, 25 team faster every year. But I also like biking to cafes and just sitting there and reading a book on my phone or eating pastries.
Got you. Now, second question is, what's your all-time favorite movie, and maybe tell us why?
This is a hard one for me. I don't think I actually have a favorite movie of all time, but one that I saw recently that I really liked is The Platform. It's on Netflix. It's a thriller, but there's a lot of underlying philosophical Easter eggs that I like discussing with friends.
Okay.
For me, I like the movie Amadeus, which is a pretty old one. It's about Mozart's life, and I'd always liked his music. And when I watched the movie, I just realized he was also kind of playful and whimsical, and the fact that he was both brilliant and kind of amusing and fun is nice.
Adding those to my list as we speak. So the third question. If you could be physically anywhere in the world right now, where would you be?
Maybe the south of France, like Nice. I also like Trinidad and Tobago. Love the Caribbean. And then also Trinidad is usually out of the path of hurricanes. So that's always good.
That does sound good. I was born in Hawaii, so I always liked the Hawaiian beach, ethos. But obviously, anywhere where I could physically talk to all of you would be great.
Amazing. I was actually born in St. Thomas in the Caribbean, so definitely appreciation for the tropical climates. Fourth question is very interesting here. So what's the lowest grade you ever received as a student?
So for me, I think it was a B, maybe a B minus, but I might have blocked that out. So, yeah.
For me, I got a C in physics one quarter in my freshman year. I didn't really like doing homework, and I didn't do much of the homework in the class. And then some tests went badly, and I was in over my head a bit because I hadn't had high school physics for 4 years before the college physics class, and I kind of forgot most of it. So it happens.
Yep. Cool. So the last question is, when you were younger, what did you want to be when you grew up?
So I went through a lot of phases of wanting to be a lot of different things. But I think for the longest period, I wanted to be an architect for a while before, of course, settling on computer science.
Gotcha.
Interesting. I also wanted to be an architect for when I was about third and fourth grade. I really liked drawing things, and then we moved from Arkansas back to Hawaii, and I switched from designing houses and so on to designing boats because I felt like it would be cool if I could convince my parents to build a boat that I designed, and then we could like drop out of school and sail around the world. But eventually I settled on computing after various other phases of wanting to be a violinist. And then in college, I was debating between going to grad school in economics or computer science. And I decided computer science was more practical.
Cool. It's good to learn more about you guys. Thank you so much for that. So great. So we have a bunch of undergraduate students joining us from around the world. Just want to say thank you for everyone that's tuning in. So I'd love for the two of you to share a bit about how you got to where you are today. So Angelica, your path to career in computing research seems to have always included a mission-driven approach. In other words, it seems you've been guided by a desire to push the boundaries of artificial intelligence in ways that benefit society. Can you tell us a little bit about that journey, and can you bring us back to undergrad?
Yeah, for sure. So I definitely saw computer science, computers and smartphones, just as they've been a way to sort of democratize access to information. I saw that through AI, they could really democratize access to other things like world-class education or healthcare. And that was really exciting to me, to think that I could work on projects where no matter where you're born in the world or what your socioeconomic status was, you would have access to things like education and healthcare. And from an early age, I knew I wanted to go into STEM. But as I mentioned, I had a hard time deciding what aspect of STEM I wanted to go into. After wanting to be an architect, even like up until undergrad, I thought I wanted to go into bioengineering, or I thought I wanted to go into ecological forecasting, a variety of other things. And I realized that the common thread between all of these things was that I just really loved working on problems that would help people, and the discipline didn't really matter as much to me. And another common thread through all of these disciplines was computer science, right? You need computer science for just about everything these days, from, we talk about driverless car technology, or programming space satellites, or even finding a vaccine for COVID-19. Computer science is playing a role in all of that, and I was so excited to get involved in this. And then it was the same kind of thing with AI. The applications and the interdisciplinary projects that you can discover within AI are pretty much endless, right? So that's what kind of got me interested in it. And then I realized, hey, I really love coding, and I really love, building models and figuring out why models aren't working and that kind of thing. So that's a little bit about my journey in undergrad. I started doing research. I started working with some professors, doing research in behavioral biometrics. So like how the way you move your mouse can be used as a form of identifying you or authenticating you. And so that was kind of my first taste at computer science research. And I was hooked from there.
So quick question on that too. So, you said that first experience was that the research that you were doing. When in your undergrad did you actually get that opportunity, and how did you go about finding the opportunity, and what were you weighing in terms of other options?
Yeah, so my goal was to try out everything. I'm a big believer in prototyping experiences that you think you might want to have, or paths that you might want to go down. So I didn't know yet, right when I first thought about getting into research, if I was something that I really wanted to do. But I knew the best way to figure that out was to try it, right? So I found a professor that I actually been a TA for, so I already knew him, and I asked him, hey, what are you working on in terms of research? And sort of got on the project informally at first. And that's something that I tell students that ask me, hey, how do I get involved in research when I don't really have a lot of experience already? There's a lot of professors out there. There are very few professors who will turn down free labor and free help. So you can kind of get on a research project that way and just figure out if it's something, come to some research meetings and figure out if it's something that you're interested in.
Makes sense. And did you have any early challenges during that first research experience that you think could have made or broke your experience and your kind of interests?
Yeah, so much of our experiences in college and in general are impacted by like our human interactions and our experiences that we have, right? So I think early on I did have some experiences where maybe I was a little bit discouraged by just the fact that I was, drinking from a water hose, and there were a lot of these PhD students who were so much more advanced than me, and having these conversations that I was just trying to understand on a basic level. And that was kind of a little bit discouraging early on, but it was just so exciting to me that I didn't stay discouraged long. I tried to take it upon myself to do my own sort of research and learning outside of classes, because I went to where I went to undergrad at North Carolina A&T. They didn't have a lot of machine learning classes for undergraduate students, so I really had to go elsewhere, learn things online and that kind of thing to get ahead and kind of build those skill sets that I needed to contribute to the projects.
Makes sense. Thank you for that. So Jeff, what's been the inspiration or the motivation for your journey? And if you could, please take us back to undergrad and kind of where you were there.
Yeah, I may even take you back a little bit before that, when I first got introduced to computing. So my dad was an epidemiologist and was always very interested in how could computing be used to sort of analyze public health data, very relevant at the time of COVID. But in general, it's useful to understand these trends and outbreaks and so on. And so at that time, sort of the way you did computing was you sort of got access to the large mainframe computer or whatever, and then you could kind of do some stuff in a very regulated way. And my dad felt like it would be better if you could sort of try stuff out on your own. And he saw an ad in the back of a magazine for a kit computer that you kind of soldered together and then you could kind of play with. And so I was about 9 at the time, so I sort of helped him solder it together. This was about a year before the Apple II came out, which was sort of one of the first sort of fully assembled computers. But then once we got it assembled, you could kind of type in game programs and play with them yourself. And I found that I really liked the aspect of taking a program and then being able to very quickly modify it to do something slightly different, right? I think that's one of the real beauties of computing is computer programs are so malleable and so quick to change things. Like I get frustrated with building physical things because it just takes so long. And when you have software, you can change it, and a minute later you have whatever you were doing working, and you can try it out. Maybe it doesn't quite work. You fiddle with it a bit more. And so I just really liked that kind of creative aspect of how do I solve a problem? How do I modify a program to do something different? And so as an undergrad, I decided I definitely wanted to major in computer science because I felt like this was a pretty cool career path. I could solve problems with software and do stuff. And then towards the end of my undergrad, I took a 2-quarter sequence on parallel computing, sort of how do you take algorithms and parallelize them, make them run on many computers, and sort of they collectively solve a problem, which was even cooler. And I really liked that class, and the Professor Kumar at University of Minnesota, who's my undergrad advisor, after I took the class, I sort of asked him, hey, can I do some research on this? And so one of the things we looked at was neural networks in this class. And so I sort of got interested in doing an undergrad thesis on parallel training of neural networks, because I felt like this was sort of during the first rise of excitement about neural networks in the late 80s and early 90s, where people felt like they could solve problems in interesting ways, very small scale problems, unfortunately. And so I felt like, oh, if we could just get 64 processors working together to do something with neural networks, it would be great. We could solve all kinds of real problems. Turned out we needed like 1 million times as much computational power, not 64 times. And so if you waited 20 years, thanks to Moore's law, we finally started to have that about 2007, 2008, with things like GPU cards and other things like that. And all of a sudden, neural networks started to really take off as a way to solve kind of real world problems in computer vision and language understanding, speech recognition. So anyway, after I did that research project on parallelizing neural network training, I sort of realized, hey, I kind of like the aspect of taking a problem, trying to figure out how to solve it in a novel way where you didn't have an obvious solution. And that I realized was research. And so I decided I would go to graduate school, although I took a year and a little bit off as a gap year between undergrad and grad school, working for the World Health Organization, doing software development for software to help understand and forecast the HIV and AIDS pandemic. And so I said, well, when else am I going to live in Europe and work in Geneva for a year? It's a good time as a relatively new graduate. So I did that, and then while I was there, I was planning to apply to grad school and eventually went to University of Washington. And I went in thinking I would want to do parallel algorithm work, but I decided I would. I really liked the compiler optimization class I took, and so I did my PhD thesis on compiler optimizations. And then when I was finishing, I was trying to decide, did I want to be a faculty member or work in an industrial research lab? When I started grad school, I was pretty sure I wanted to be a faculty member. And then as I interviewed, I sort of looked at both kinds of places, and I liked the industrial research setting where you basically get to focus on research problems full time, and you have a little bit more direct outlet into getting that stuff used in the real world. And so I ended up going that way. I also didn't get interviews in grade schools, so that helped make the decision. And so then I ended up in an industrial research lab for Digital Equipment Corporation for about 2.5 years. And I realized it was a little bit hard to get the work that I'd done out into real products. It's sort of, the product group was very structured and had like already 2-year roadmaps. And so they're like, oh, that thing's really cool. Maybe we can slot it in for 2.5 years from now. I'm like, oh, that seems really long. So I decided I wanted to go to a smaller company. It being Silicon Valley, I decided, I should try something pretty small. So I ended up coming to Google when we were about 25 people. And we were all wedged in this little small area above what's now a T-Mobile store in downtown Palo Alto. I was in a little teeny office with 2 other office mates, and we couldn't all roll our chairs back at the same time because we couldn't all stand up. And then, the thing I liked about being at Google is the company's goals are really broad. So we want to sort of take digital information and organize it and make it useful for people. And that has a whole bunch of interesting challenges in lots of areas of computer science. And so I felt like it was a really nice place to have lots of interesting problems to work on. And if you sort of finished one area and you wanted to go off and learn about a new kind of problem area or applied problem area, there were lots of opportunities to do that. And so that's where I am.
Got you. And you've been there for how long now?
21 years.
Wow. And still finding new problems to solve.
Indeed. Yeah.
Amazing. So building off of that, you're responsible for so many innovations in computing and artificial intelligence, both in and out of Google. What is your approach for finding those big problems, like we just talked about within Google, that are also rich enough to keep your attention for a long period of time? And, as a follow-up to that, what advice would you give students who are trying to find those meaningful big problems to work on to make the world better? Yeah,
I think actually, as Angelica was describing, the I'm motivated when I can find a set of problems that I'm interested in solving and where I kind of can jump in and I don't know everything about that area. And so I can work with people who know a lot of different things than I know. And sometimes that's because they have different kinds of expertise than they have. Sometimes it's because they have more knowledge in an area that I do have some knowledge on. But where, I can make a contribution, but at the same time be learning a lot of stuff. And so I try to find things where I think this is an ambitious set of problems that if we set out for the next, 3 to 5 years, that we could really make progress on. And if we're able to make progress on them, that's going to be important in some way. Maybe it's going to allow us to solve new problems in language processing or in, applied areas like healthcare or, a bunch of things like that. And where, you get together with a group of people and in the course of doing work in that area, some of what they know kind of rubs off on you, some of what you know rubs off on them, and you all collectively can solve problems that none of you could solve individually because you don't have the full set of skills, but where coming together enables you to collectively solve problems and learn at the same time. And I think that's a really good thing. I think for young students who are thinking about what they want to do, I think that's a really good hallmark is, can you put yourself in a place where you're working on a problem you think is really important, but also where you're going to learn a lot in the course of doing that work, and you get to work with people who know different things than you do. And you shouldn't do that only in school. Like, you want to continue to do that throughout your career so that you keep learning new things, because once you've done 12 projects and learned things in those, the 13th one, you become more effective because you already have the knowledge of the previous 12 things you've done. And the 13th one, you can also learn new things.
Yep, that makes complete sense. So Angelica, you've shared your passion for the intersection of technology and social change, right? We've touched on that a lot. Can you talk a little bit about how you believe in, in your experience, the that word kills me, interdisciplinary applications of AI and machine learning can play a part in, for example, reforestation efforts in Rwanda, help teachers make better education decisions, and help young people make better eating choices?
Yeah, for sure. So these are some of the areas that I often talk about and love chatting with other people interested, as Jeff mentioned, from different backgrounds, and figuring out how we can solve these challenges. One thing that's sort of a commonality with all of these is that there are basically two things that you want to think about. The first is on the human side, what is that true human problem? What are all the sub-problems that are related to solving this? And what are the other human factors that you need to consider? So those are all on the human side. And then what does the data look like? What is the data that can help you solve these challenges? So when it comes to reforestation, so I worked on a few projects related to this. The first one, I was actually an intern at NASA, and we were working with the Republic of Rwanda's Ministry of Agriculture on reforestation efforts. And we were actually using NASA space satellite imagery. Now, why would we be doing this in the United States, in Virginia, Langley, Virginia, to help solve this problem, halfway around the world? Well, there's so many considerations that you want to think about. You can't just say, I want to plant trees everywhere in Rwanda, right? There's so many considerations that you have to have. And a lot of them related to the fact that Rwanda, like 70+% of Rwandans are subsistence farmers, right? A lot of their GDP comes from coffee and tea plantations. These are factors that you want to consider in reforestation, and we can actually use NASA space satellite imagery to understand the topography and land use of different areas in a way that folks on the ground and NGOs on the ground just don't have access to. we can do things like use nightlight imagery data to see how people and technology are kind of moving around. We can differentiate between like natural light and electricity, and kind of get some really cool data to kind of use in ways that maybe wasn't initially intended for, but can help us solve this issue. So we created a lot of risk maps associated with where the best places were to reforest. So that's just one example. You know, there in healthcare, right? I now at Google, I work in Google Health. There's so many ways that AI can play a role in healthcare on the patient side, helping doctors make smarter decisions, better care decisions, diagnosing certain conditions from medical imagery is what I do in my day-to-day. With education, you know, what if there was the possibility to have AI tutoring systems? This was my grad school research at Stanford. You know, how can we have AI tutors that understand how each child learns best and can generate custom educational content based off of how they learn and what they're interested in, and can kind of flag areas or opportunities for additional learning for teachers. But I'm most interested in like what the next generation has to say about this. You know, I have a lot of ideas, and I've worked on a lot of things, but I'm really interested in, one, democratizing access to CS and AI education, because I feel like the best people to solve problems are the people who are actually facing them. And so if we can work alongside people, you know, who are in communities that need AI solutions, we can come up with much more robust solutions to these problems. You know, I can talk about tons of examples of that. I could talk about that for days in terms of times when so in undergrad, I actually started a community-based makerspace that focused on CS and AI education, and we solved so many. Well, I won't say solved, but we worked on so many really cool, interesting problems related to the problems that were facing people in the communities surrounding my undergrad. So again, just democratizing access to AI and CS education, I think, is going to be really pivotal, and getting these you know, social good projects from the design and research stage to actually making a difference in our communities.
Amazing. Well said. So quick question for both of you, actually. What is the difference between, you know, being a regular software engineer, I don't want to say regular, but being a software engineer and being a computer science researcher? And I know, and the reason I want you guys to touch on this is because a lot of students are probably seeing way more software engineering internships that are, you know, marketed to them and more accessible to them, as opposed to research opportunities. And so I would love for you guys to shed light on what the difference in the day-to-day or the end goal of a project may look like between software engineer and a computer science researcher.
Sure, I'll start, and maybe you can add in, Angelica. I mean, I think the difference in my mind between sort of software engineering and research is a bit blurry, right? It's often in software engineering, you have a pretty good idea of what you're trying to build, and you have a set of things you need to do, and maybe there's dependencies, you need to finish this, and then when that's finished, then you can work on these two things. Maybe you're working in a team, and so, you know, you've distributed the work that you're doing, but it's fairly clear what it is you're trying to achieve. And I think in research, you're trying to answer a question or understand how to solve a problem where you're not really sure how to solve it. And so you're essentially thinking about this problem. You think this is an important problem, or at least a broad direction to go in. And then you think, you know, a bunch of sort of basic ideas and techniques might be able to be assembled into solving a problem. That's kind of the kind of research I tend to do, which is a little bit more hands-on software engineering, writing software in order to solve research problems. There's lots of other kinds of research that are not that. There's like very theoretical kinds of computer science research where you're trying to understand algorithmic properties. And there it's a very different mode of working. You're still trying to solve some unknown problem, but you may not be sort of actively sitting at a computer and writing software. You may be sort of doing more mathematical analysis of things. But for the kind of research I like to do, I find that, just working through the unclear parts of the problem is the research process. And if you set an ambitious enough goal 3 or 5 years down the road, I think we can solve this. Often it's the case that some of what you've done so far in achieving that, working towards that goal is useful in its own right. And so it may throw off kind of useful intermediate results along the way to a larger problem that you're trying to solve.
Makes sense. Angelica, any other thoughts on that?
Yeah, I think Jeff hit the nail on the head for sure. There's a lot more uncertainty, I'd say, in research than traditional software engineering, but there are a lot of overlaps between the two. I think in research, you have to be a little more comfortable with quote unquote failure, but it's not even really failure because you're learning something. So if you have the mindset like, oh, I'm going to try out this experiment, I'm super excited about it, but it fails and you're still excited, like, oh, well, wow, that's interesting that didn't work. You kind of have to have that mindset to kind of stay excited and motivated about it. And I think like natural curiosity goes a long way. I think in both software engineering and research, but particularly in research when you're doing a ton of very plausible experiments and trying to validate hypotheses, and it's just not quite working out.
Yeah, maybe I'll add in a couple things. I think there's a really good delicate balance to get right in choosing a research problem that is hard enough and uncertain enough that you may not be able to make progress on it. And that's kind of an uncomfortable feeling for a lot of people, versus one that is very comfortable and you can almost virtually see all the steps to get to where you want to go. But sometimes those problems tend not to be ambitious enough, right? They tend to be the ones that you can fairly clearly see the solution to and may not sort of move the world forward as much as one where there's a lot more uncertainty, but the reward for solving that problem would be higher. And that's kind of a tricky balance to get right as a young researcher, I think. One other thing that I often give advice to students about is a lot of research is understanding the core of a problem and how you're going to put together 5 or 6 things that you vaguely have ideas around and solve some other things like the 7th and 8th ideas you'll have to come up with. And that's why it's really important to have kind of a passing knowledge of a lot of different things so that you can sort of combine together these 3 ideas that you vaguely remember from some paper you skimmed a long time ago, and this 4th thing you'll have to come up with, and those together kind of form the essence of solving a new problem.
Makes sense. Thank you for that. So another question for both of you, just based on your experience, your network, what you've been observing, what are some exciting areas in AI that you think undergraduate students should be paying attention to right now and maybe even developing their skills in?
Yeah, so I think this probably sounds pretty cliche, but I think it depends a lot on the interests of the student, what they're passionate about. There's so many aspects to CS research and AI that, especially like the interdisciplinary component, if you find something that you're really passionate about, there's probably a way, an interesting way to combine it with computer science or AI. But that being said, I think generally speaking, in addition to knowledge and know-how when it comes to developing ML models, when it comes to AI research, strong data engineering and data science skills sort of never go out of fashion. a lot of the time that you spend in doing research in AI is going to be related to your data, understanding, if there's any biases in your data, understanding if your data is clean, accurate, representative. Because if you don't have that, you really don't have an AI project or an ML project. And then just getting that data in the right form to work with, and then analyzing the results that you have and saying, I wonder, what's going on here, why these results are coming out the way they are. So definitely that data engineering, data science skill set.
Gotcha.
Yeah, and for me, like I think a lot of it depends on what you're interested in. So I think we're at a really, really exciting time in computing. We've basically gotten it so that computers can sort of see and perceive the world much better than they could a decade ago. And that's like, if you think back to evolution, when animals evolved eyes, like that was probably a time of great change. And now we're at the point where computers can sort of start to perceive the world in really interesting and new ways. And you can imagine solving all kinds of different problems, some in very applied areas like using computer vision in medical diagnosis or educational tutoring, or lots of things that Angelica mentioned. In terms of kind of areas that I think are going to be really important that we're just starting to kind of scratch the surface on now in AI, I think one of the main problems we have in machine learning and AI is we tend to say, oh, this would be a great problem to solve with machine learning. And we collect the data set and we do a bunch of experiments to figure out what the best way to use that data to solve the problem, to get an effective model of this problem we care about. And then we have another problem, and we sort of do that whole process all over again. So we effectively start every problem almost from scratch, right? We're effectively solving hundreds or thousands of different machine learning problems where each model is targeted at that particular problem and starts with effectively nothing. Like it's essentially initialized with random floating point numbers. And that's completely crazy to me, right? It seems like that's like every time you want to solve a new problem, you forget your whole education and you start over from scratch, and great, you do all the education you need to do to solve that problem, and then you do the same thing on the next problem. So I think the area of multitask learning, where you have a model that can solve many, many tasks, multimodal learning, where you have models that can flexibly take in lots of different forms of input, take in, text, language, videos, audio, other kinds of data, and be able to effectively solve new tasks. And then when you have a model that can do, say, 10,000 things, and the 10,001st thing comes along, you want to be able to leverage all the expertise that this model has developed in doing the first 10,000 things and say, oh, this thing seems very related to these other 7 things I already know how to do. So I'm going to sort of use that as the basis for how I kind of get to a good solution for the new thing. And I think there's a whole bunch of interesting problems in there in the areas of computer systems. How do we engineer a machine learning system that can effectively solve problems at scale with lots of interesting new computing hardware? How do we have lots of progress on interesting machine learning problems? Like there's a problem called catastrophic forgetting, where if you try to train a system to do the 10,001st thing, you don't want it to all of a sudden forget how to do 33 other things. And so how do you balance that in machine learning algorithms so that you make progress on all the things you care about rather than forgetting some things? How do you actually make sure that the system doesn't have biases that are harmful or dangerous? Depending on the data it's trained on, that's a very real possibility. How do you actually make use of such a system in solving real problems in the world? So I think there's tons of interesting problems, and a lot of it depends on what you're most interested in.
Yeah, for sure. And I think you touched on a point at the end that I think would also love to hear both of your thoughts on, just about bias and kind of ethics in these new problems that we're throwing AI and machine learning at. So any thoughts on kind of where that comes into play in the field, and any advancement that you're seeing in terms of kind of baking ethics into the kind of genesis of some of the applications of this technology?
Angelica, you want to start?
Sure. Yeah. So I think bias is really a tricky problem that a lot of really great, smart people are working on. It is manifested in data sometimes because, we have biases in society, right? And so when we think about being good actors and building technology that works for everyone, we want to make sure that we don't, one, introduce new biases, but also that we're not reinforcing biases that already exist in systems. Like, that is not okay. It's not okay to say, just because, well, this is how the data is, this is how, our models are going to be. So I think the first step is sort of everyone recognizing that. And when I say everyone, I mean not just the people building the models, but also, our policymakers, the people in education systems that are going to be buying AI software, the people in, the judicial systems that want to use AI for various reasons. We need to all be aware of this, and that means all of us. And yeah, I think that's my key overall message in terms of just understanding, making sure that we all understand that it's not okay, and calling it out when we see it.
Yeah, I mean, I think the fact that we're building often on data about the world, and the world is the world as it is, not the world as we would like it to be, is a really important thing to realize as we start to think about how could we apply AI or machine learning to solve this problem or that. I think first you want to understand what are the biases that could be present in the data you're collecting to solve a problem or the data you have available. The bias in algorithms, certain kinds of algorithms can be biased to prefer one kind of solution over another, and that can sometimes disproportionately harm certain kinds of subpopulations in the problem you're caring about. For example, if you had a dermatology model and to diagnose skin conditions, and you had no data about people with darker toned skin, that would not work very well for them, for their solutions. That's a data problem. I think the fact that we can solve a problem doesn't mean we necessarily should. And so it's good to have a set of principles by which you look at how you want to apply AI and machine learning to all the different problems in the world that you could imagine applying them to, and have a set of principles by which you evaluate, is this actually a good problem to tackle? If I do tackle it, what are the ways in which I want to make sure that the solution is equitable and fair for everyone? Google actually has a set of principles that we've published openly by which we think about looking at new problems and making sure that we're upholding the principles we believe in, how we should look for solutions and biases or other kinds of harmful things that might be present in problems that we solve. So it's an important area, and the fact that computer vision or other kinds of technologies now work so much better than they did 10 years ago really means the risk of these kinds of things is much higher, and it's really important to be cognizant of them all and to be considering them as you solve new problems.
Amazing. Thank you for that context, that perspective. Great. So it's been really great having this conversation with the both of you. Before we get into the student Q&A, I know the students are eager to ask you guys some questions. Just want to get some advice from you guys. The whole world is feeling a little bit more challenging these days for various different reasons. So what advice do you have for the students watching that would help them navigate these complex times, maybe even from the individual perspective, social perspective, academically, professionally, whatever area you feel best equipped to kind of give that advice?
Yeah, I mean, I think 2020 has been an incredibly challenging year with so many different things that are unusual or unexpected or very harmful from a society point of view, from an ecological point of view. You have the pandemic, which has completely changed how we are operating as societies. We have things like the George Floyd murder and the outrage justified from that, and the anger that sparked, and then you have things like the wildfires in California. I live in California, and the sky 2 weeks ago was like this apocalyptic orange. The winds have picked up a little, so it's better now. I think it's important to realize that this is an unusual confluence of events that hopefully is worse than the future will hold, and things will get better, and that it's important to keep working to make society and the problems you really care about and better, and solve problems that you think are important and are going to advance all of us collectively. Try not to focus on the negative aspects of what's happening now. Try to focus on the few positive things you can see and to build on those, and to make sure to reach out to people to check in how they're doing. If you need to talk to someone, reach out to people that you trust and can, just have conversations. I think it's really important to make sure people don't get too isolated in this time, because it is very easy to be isolated.
Yeah, for sure. I would +1 all of that. And I would say, we've got to remain really steadfast in our values and remain empathetic to others, throughout all of this craziness. And I would say, whenever possible, try to flip some of these challenges into opportunities in disguise. Maybe that's an opportunity to just reflect on and learn from a difficult or a tragic situation that we are seeing so much of. Maybe it is an opportunity to stand up for something that you believe in. And maybe it's just saying, hey, I've been stuck in the house, during this pandemic. I have some extra time on my hands. Maybe I'll invest that in myself, invest that time or into my education, into my future, or investing that time into the well-being and future of others with volunteering. I think that's always time well spent. And as the world is kind of seeming to go crazy, you can sort of take comfort in that you are not, in fact, contributing to that craziness, but in fact, contributing to some positivity in the world is always comforting.
Yeah, for sure. One thing I had to do was accept the fact that, things are just going to be delayed, and that's okay. I won't be as productive as I was maybe 12 months ago. So yeah, definitely tough and challenging times. But thank you for that perspective. It's been a pleasure moderating this fireside chat with you, and I know some students are ready to ask you both some questions directly. So let's get started with our student Q&A. The first student will be Melissa Mitchell from University of Washington.
Thank you. So my question was, what's the most challenging project or experience you've had in your career so far? And what did you learn through that process of working through it?
Okay, I'll jump in. I mean, I think when I first went to graduate school, I was pretty set on being a faculty member. And then as I got towards the end of my graduate school career, I published some papers, not maybe as many as I'd hoped or whatever. And I sort of really realized I was not going to get a faculty job at a kind of a top tier research institution, which was kind of how I felt like I was, really trying to go to graduate school to do. And so I sort of pivoted what I wanted to do and said, I really want to go out and solve research problems that are important. And I don't have to be at a particular kind of institution for that. I can just focus on trying to solve problems that I think are important. And so I pivoted to industrial research and eventually came to Google. And that's sort of, a branch in my career, a left turn, as you will, that has worked out very well for me, but I think was kind of disappointing and hard to take at the time.
Yeah, and I think for me, one of the most challenging times for me, but it was actually also very rewarding and helped me learn a lot, was actually my senior, or not my senior, but my final year of grad school, I actually decided to launch a startup as a full-time student and doing research on campus. So this was just a challenge in itself. I'd seen this sort of chicken and egg problem where, I felt like startups with non-technical founders had these really great ideas, but they couldn't necessarily get funding because they didn't have, like, if the project was related to AI or computer science, they didn't have prototypes or a technical team yet. It was hard for them to get a technical team because they didn't have, that funding to get those high-skilled individuals on board. So I started an AI research firm, and at the height, I think I was managing like 10 people. This was a lot of craziness, but I learned so much in terms of what it's like to build AI in a startup environment, with a lot of challenges, not a lot of resources. And for me, going back to this idea of prototyping experiences, I thought I might want to launch or join a startup one day. So this was a great opportunity for me to do that. And I realized that this was on the whole other end of the spectrum from doing research in an academic institution. And so having that other end of the spectrum experience really helped me realize that I wanted something a little bit in the middle. And so Google for me was that kind of thing in the middle where, Google AI, in some ways it's almost like a research institution, but in other ways, particularly in a lot of the teams that I interface with, we operate a lot like a startup. So it became this like happy medium. And that was like a big learning experience for me, for sure.
Thank you for the question, Melissa.
Thanks.
Amazing. Thank you, Melissa, for the question. Next, we have Kimberly Alvarez from UC San Diego.
Hi, my question is, what advice would you give someone who would have given when you started grad school? Sorry. And did you know what you were going to do after grad school? And did those plans follow through, or did you find something interesting?
Angelica, you want to go first?
Sure. Yeah. So I used to struggle with this question of like, what would I like have told myself when I was starting grad school? Because honestly, I feel like looking back on the experience, there's nothing major that I feel like I either regret or that I like would have done differently. Of course, there are like a bunch of little things, but they almost seem trivial. And that's not because of me. That's not because I'm like this great, awesome person at navigating higher ed. It's because I was so incredibly fortunate to have amazing mentors and support systems and people sort of ahead of me on the path that I wanted to go down. And so I would like flip this question a little bit to what, like, some things that I'm so glad I knew. And the number one thing was, that these mentors would be so impactful to my experience. And so, mentors also don't have to be like, Jeff Dean level in terms of their awesome, amazing accomplishments, right? They can be like that person, that peer that's maybe just a year ahead of you, maybe is like had a year of grad school down already, that you can talk to and gain experiences from. And then another thing was like, fellowships in grad school were really helpful to me. And I'm glad that people told me, hey, apply to these things, because it gave me a lot of freedom in grad school to work on the projects that I was interested in. So one of them was like the NSF Graduate Research Fellowship. And so through that fellowship, I was able to sort of design the research experience that I wanted to have at Stanford before I even stepped foot on campus. And then in terms of where I ended up, I ended up where I kind of wanted to be at post grad school. I struggled with like knowing what I wanted to do in the next in the 3 to 5 years after grad school. I knew, and I still kind of know where I want to be, 10 years from now. But there was sort of a lot of ways to get to that point. And one of those awesome mentors told me that, I spent a lot of time struggling with this, like, oh, should I do this? Should I do that? Like, what should I do? And they told me that, and this was a non-computer science person, but they gave me a really good computer science analogy. They're like, there's all of these nodes on the path to where you want to go, and you're trying to like brute force it and like try all the different possibilities and figure it out step by step. But you really need a heuristic approach. You need to just try one thing and see if you like it, and if you don't, go back a step and maybe try something else. If you like that thing, keep going down that path a little bit. So that's the the heuristic approach was. And that really helped me figure out what I wanted to do. And so I did an internship with the team that I'm on now. And once I spent time that summer with that team, I knew that I was hooked and that was a place for me. So it's a little bit how that went.
Yeah, maybe life is a mix of breadth first and depth first search. We should not use one or the other. I think when I first started grad school, I was pretty convinced I was going to grad school to do kind of parallel algorithm research. And then, a year in, I sort of switched and did compiler optimization work because I kind of got hooked on that. And so I think, it's okay to have a vision of where you want to go and then change that as you get new information or you find something that is different. But I think it's really helpful to make sure that what you're working on is something you believe in and you think is important and that you're learning from doing that. And I think that's the most important thing in my mind. One thing I would say is, since many people on the call are undergrads, is to try to figure out a way to get involved in some research as an undergrad. If you think that might be like what you want to do and go to grad school, it's really good to get a taste of it in some way. There's often lots of opportunities to do this but you have to be a little proactive. You have to reach out to a faculty member and say, hey, I really liked your class, or I really like this topic. Is there some way I could do research in your group or on these kinds of problems? Often when I was an undergrad, the NSF Undergraduate Research Opportunities Program, which I think still has that name, I'm not sure. It has a way for you to write a little proposal as an undergrad and get like $1,000, and that can sometimes be useful to sort of make it possible for you to focus on doing research without giving up opportunities where you might have to be working to earn money for school or whatever. I think things like that are really important to get a taste of what research is like, and getting good mentors is obviously really important. People to give you advice about, oh, you should go check this out, or this seems like a good problem, or, hey, let's work together on this.
Thank you so much, Kimberly, for your question. So next we have Ola Wepo from Alabama A&M University.
Hey, Jehron, my question was, what was your biggest motivator in starting a startup right after college?
Thank you for the question. For me, obviously ColorStack has its mission, right? But I think for me, as a founder, we're pretty similar to researchers in that we want to solve big problems in the world and are okay with kind of, failing, or not really failing, but learning from different attempts that we make to solve that problem, like Angelica noted earlier. And so for me, I knew I wanted to, start a company from even in high school when I started my first business. And so, the reason I chose computer science in college was because I felt that was a great way to solve problems at scale. Right. I think it was a great way for me to test out things very quickly and put solutions in people's hands very quickly as well. And so once I fell in love with software and kind of writing code, I knew that this was going to be my ticket to entrepreneurship one day. This was going to be the foundation that I needed to go about, taking these problems that are out there in the world and breaking them down into small steps, right? That's what computer science is. When you first learn, it's like, you think you know how to, add two numbers together, but really you don't know, how to articulate all the steps that goes into that. And so it taught me how to take huge problems and breaking those down into step-by-step solutions. And I think that was the foundation that I needed to go out and pursue a startup right after college, because now I feel so much more confident in my ability to solve problems in general because of this computer science foundation. I joke about this with my mom sometimes, like, yeah, I got a computer science degree. I'm probably not going to write software ever, but that degree is going to help me so much more in the long run, in my opinion, than like a business degree would have. So yeah, that was kind of my journey into like choosing computer science and why that I think helped me become more confident in starting a company. I think the reason I wanted to start a nonprofit helping specifically racially underrepresented computer science students was because of my experience at Cornell, helping out with their participation rates. And I never really envisioned that work going beyond Cornell. But once people are kind of pulling the product or the business or the idea out of you and saying they need it, you kind of just have to answer, right? That's like the easiest, nonprofit or startup or whatever thing to deliver, is the thing that people are asking you to give them, right? Not guessing, right? They're just saying, can you bring this organization to my school, or can you bring this to serve more students across the country? And so as I started talking to more students, it became very clear that this was needed at scale, and talked to a few mentors. And they kind of gave me advice on how I could go about like funding it, and things like that. And out of all those signals and support, it gave me that confidence yet again to say, okay, I'm going to give up that product management or that software engineering role to pursue this problem that I really think I have a great chance at maybe not fully solving, but moving the needle on. Yeah, thank you so much for that question, though. So the next question is from Khalil Guy. He's from Fisk University.
Hi, how are you?
Great.
Thank you.
All right. So my question is, so what does research look like at Google? Is the process and structure of how the research is conducted different from that in a university or national lab? And if so, how?
Yeah, I mean, I think I'll tackle this since I have a pretty broad view of it. Google Research is a pretty large organization, so we're several thousand people, and we're distributed all over the world. So that's one major difference. We probably have people in 44 locations around the world. We're working on a really broad variety of problems in computer science and beyond, in areas like climate science and healthcare and physics. And so we tend to be organized into smallish teams investigating some particular line of thought. I think the way we're organized and figure out what we want to work on collectively is kind of twofold. So one is there's a few areas we think are really important, and we sort of say, hey, this seems really important. We should really have people investigating, how we can solve like the problem I was talking about earlier. How do we have machine learning models that can solve tens of thousands of tasks? That seems important. If we were able to make progress on that, that would be good. And so we have a bit more of a structured effort around having more people investigate those kinds of problems. But you're also a research organization, and what you really want is the best collective ideas of everyone to be contributing to what it is that we do research in. And you don't want like 5 people to say, okay, here's what we're doing. And so a lot of what we do is kind of smallish research projects that get started because 1 or 2 or 3 researchers decided this was an interesting problem, and they'll go investigate it. And it being research, sometimes that won't work out, and they'll switch gears and do something different. Sometimes it'll look like they have promising early results and that we really should be doing more in that space. And so we'll, work more on that. We also have this tremendous set of interesting problems that crop up in our product and what we could do in our products if we were able to solve this kind of problem. And so, the fact that computer vision now works has meant a tremendously rich set of opportunities for collaborating with our product teams to get, interesting computer vision features or models into lots of our products, and also to create new kinds of product directions that we should go in. Like a lot of our healthcare work is because we started doing work on how could machine learning be applied to healthcare, about 7 years ago, and got a bunch of really interesting early promising results. And now we have sort of a much more focused effort on how can we actually bring those not just into research papers, but into real world, use in healthcare settings and consumer settings. So I think it's a kind of a mix of things. The distributed nature of it, where we have people all over the world, makes it more different than a university where everyone's usually in one place or a national lab or something. But it also means that we have perspectives that people get from living all over the world and finding interesting research problems they might want to tackle based on the sort of local environment that they're in. Like people in our Accra, Ghana lab find local problems that they see near Ghana that are different than the ones our researchers in the Bay Area or in New York see. And I think that's a good thing to kind of keep in mind.
Great, thank you.
Cool. Thank you for the question, Khalil. So next we have Arjun Krishnan from Princeton University.
Hi, yeah. So I was just curious about how different teams interact within Google Research and how often they work together, and if there were any particularly interesting examples of productive or interdisciplinary collaborative efforts between teams.
Yeah, maybe I'll jump in and then maybe you can talk about some of the healthcare work, Angelica. So I think, there's all kinds of different ways of working together. Sometimes it's a small team focusing on a particular kind of problem, and there's another team that is focusing on that rough problem with a very different approach, and they kind of share ideas and sort of directions, or maybe they share sort of benchmark results or benchmark problems that they're both working to solve, and sort of seeing how they how one approach might be solving some of them better than others. And I think that's a really important lesson, is that you want to work collaboratively with people often pursuing similar problems, but not exactly the same ones, and with different approaches. Because what you ultimately want to do is make progress on those problems, and you want to combine together the best ideas from many different areas. And often the teams that we put together for different problems are very interdisciplinary. So we have some people working, for example, on machine learning with an external company that is trying to build fusion reactors. And so they have these giant 50-meter long fusion reactor prototypey things. And there's a whole bunch of knobs that you can fiddle with. And so they have a lot of expertise in how do you build these machines and how do you operate them. And we have a lot of expertise in, how do you set knobs in machine learning in interesting systems. And so that's a nice example of a collaboration where, the different skill sets really are needed together to come together. So our machine learning models will come up with a set of knob settings, and then the people who know about the knob setting would be like, "Oh, well, we shouldn't set that knob to 7 because the machine might blow up." And so the domain expertise is actually pretty important. And I think, those are the most fun research projects because you get a lot of interesting lessons for your own, education in working with people who know different things.
Yeah, awesome. And yeah, for health in particular, we have a lot of teams working on not really related tasks, but tasks that use the same types of technology and underlying infrastructure. So, which is really helpful just when you're building code together, but applying it to different domains. So we have people working on, dermatology diagnostics, radiology diagnostics, all kinds of things, prostate cancer, and so being able to collaborate on that level is really great. And then kind of on the other end of the spectrum, we also have these really cool research conferences within Google, where we all kind of get to share across the company, across Google AI, what we've been working on. And that's not only just tactically very helpful, but it's also super inspiring. Another kind of like win for us as a company in terms of collaborating between research and other areas. Google Health just announced recently the release of COVID-19 open data repository. And so that was a collaboration between Google Health, between Google Cloud, even Google.org. So there were a lot of different people involved with that. And so if anyone's kind of looking for a cool side project, maybe check out that data set that we just released.
One thing I'll add to collaboration is we actually want teams to work together. Like often people will start investigating problems independently that are similar and then find out, oh, these other people are also doing this. So we actually have a goal within research that at least, N times per year, teams that are working on similar problems actually decide to join forces and start working together. Because I think that's kind of the collaborative spirit you want to foster. And it's good to set goals around things you want.
Amazing. Thank you so much, Arjun, for your question. So the next student we have is Adwait Chavan from University of Illinois at Chicago.
So I wanted to ask, what is your vision about widening the reach of computer science to those children who come from financially unstable and educationally unaware backgrounds?
Yeah, I mean, I believe really, really strongly that we need as an industry, as a field of study, to create opportunities for people who maybe don't have as much opportunity as they're in their early education. You want the best people in the world to be excited and solving the most important problems in the world, but not everyone has the opportunities that many people do. And so I think having a lot of outreach and ability to find people who might be interested in this, expose them to this as a possible career, give them opportunities to, investigate whether this is something they might want to do, and then make sure that they're not at a disadvantage because they didn't have a laptop from age 9 and were programming from age 9, but instead first got exposed to computing, when they went away to college or when they, found some program that enabled them to, first get exposed to these ideas. I think this is super important. I think this comes partly from my own background of, I lived in so many places growing up, including Uganda and Somalia and, Hawaii, Arkansas, Minnesota, many different places in the US and outside. And what I found was that, people are amazing everywhere if given the right opportunities. And so you really want to make sure that those opportunities are made available to people who will take advantage of them, who are motivated, who want to work hard, and who want to sort of, advance what it is we collectively do.
+1 to all of that, yeah.
Thank you.
Amazing. Thank you for your question. Cool. So our second to last question here is from Ivani from Stanford University.
Hi, nice to meet you virtually. My question stems from Richard Hamming's talk on you and your research, and is how do you decide what problems are important to work on?
Angelica, you want to take
Yeah, sure. So if you ask like any team anywhere, you're probably going to get a slightly different answer on that. I think within health, there are some key things that are important to us. I think number one is potential impact. Understanding how the projects that we are interested in are going to impact our users, be them, patients or doctors, is how much do we think we can reduce false positives or false negatives, for example, in diagnoses, or how many lives do we think we can save? How much time do we think we can save doctors? I think that plays a huge role in terms of what projects we are interested in working on. And then, of course, the solvability, if you will. So, sometimes you need to do a little bit of research and discovery and experimentation to even know the viability of a project. But we also understand that, AI isn't this kind of like magic tool that solves everything, for a variety of reasons. One of them being, access to high quality data. And so that's kind of an important factor as well. And then I think also there's this kind of nuanced element that I've seen across Google, in terms of wanting to take on projects that we are uniquely positioned to drive because of our expertise, and there's some projects that we are super interested in, but maybe decide to work on in partnership with very like Google's or another alphabet company, so Google's sister company in life sciences on some projects, for example, or DeepMind. So I think there's a lot of considerations that have to be made, and oftentimes there are a lot of projects that we really want to work on, and maybe we will in the future, but the timing is not right. Timing is important as well. So yeah, a lot of things to consider. Sure.
I'll ham it up a little and say that my advice is probably some distance away from Richard Hemmings, but I think for me, I'm going to take a little bit more personal tack, which is I think when you figure out the way to figure out what problems you want to work on are ones where you think it's an ambitious enough problem that it's researchy, not just kind of engineering, right? Like you want something where you don't actually know how to solve it, but you think solving it is really important for maybe some applied area or maybe some advances you think then you can build on and then go to the next set of problems. And for me personally, that usually means picking a problem that I want to focus on, or a rough area of problems for the next kind of 3 or 5 years, and say, okay, I think we should go in this direction. So my current example is, how do we make machine learning models that are able to solve thousands or millions of tasks rather than just 1 or 2 or 3, right? And there's a whole bunch of sub-problems in there. But obviously, if we were able to do that, that would be really important, because you could then be able to have a model that can adapt to new things and can solve new tasks with less data, with less preparation, with less ML expertise needed to solve the new thing. And so I think that's the kind of thing I like to find, is one where you have a vague vision of where you want to go. You have some ideas about things you might need to bring together to go in that direction. There's going to be some unsolved problems that you haven't even contemplated yet, but you can probably meander your way through. I personally find it motivating to have that 3 or 5 year horizon, not 20 years, because 20 years feels a little too far out. There's too many, there's this cone of uncertainty that grows with time. And I like to be kind of in that 3 to 5 years sweet spot for me, not 20 years out, because there's just so many things that could change in that longer horizon that I find it hard to kind of actually find practical research problems that are that long term. But other people are different. So for me, that's what I like to do. And often there are problems where I can work with people that I want to work with, that I think I'll learn from. And so where I have some of the skills to tackle some of the sub problems, but not other ones, and where we all are going to have to come together.
Thanks.
Thanks.
Thank you for the question. We have our last student question from Jessica. She goes to UC Irvine.
Hi. Yeah, my question, I was just wondering what you think is the key to getting more individuals from underrepresented backgrounds into areas like AI or machine learning, and if there are any certifications, online courses, or projects that you recommend to kind of help supplement our college coursework to get into those?
Yeah, for sure. So I think on the one hand, exposure is really key. So helping young people, whether they're in high school or in college already, understand, hey, what is AI? What is it really? We talk about all these buzzwords, but how is it helping people? How is it making a difference? That kind of thing I think is really helpful. I mentioned working on a community makerspace where we worked with high school students to expose them early to CS and AI. That was so eye-opening to me to work with these students who, once they had an idea and kind of had some very basic knowledge around AI, like how far they would take that and be excited about it and be excited about how it can impact their own communities. And so like the students at one point, so in North Carolina, where my university is, was actually like #1 in the nation for food insecurity, and not too far behind that was obesity. And the students like created this entire application in Android that like leverage computer vision with Google Cloud APIs and all of this cool stuff to combat these issues by just taking pictures of the items in your refrigerator and pantry and generating healthy recipes based off of that, and then connecting you to area food resources. I would have never come up with that. I lived in North Carolina for all that time, and I never knew these issues that were kind of facing students. So they love to take ideas and run with them. And if you can, the earlier you can expose students to CS and AI, the better. On the other end of the spectrum is opportunity. So even if you know about all this stuff, it's like opportunity begets opportunity in a way. So if you're already kind of underrepresented, under-resourced from these backgrounds, it can be hard to kind of get your foot in the door. And so I think one thing that both Jeff and I talked about was trying to get exposed to research early on in undergrad. And so, it's great if you can get sort of a paid position or something like that. But just finding a way to get involved with a research team, just learning about what they're working on. And that's kind of like a first opportunity that you can then, once you're kind of in that team, the professor is more likely to take you on as a, with a research position, or give you a letter of recommendation for a grad school, that kind of thing. So you really have to kind of find ways of creating your own opportunities and finding opportunities from companies like Google that are doing all these outreach initiatives and that kind of thing to really help you get your foot in the door.
Yeah, I mean, I think exposure to these kinds of problem areas and disciplines is a really good thing for people to have at lots of different stages of their education. And many people don't have the opportunity to be exposed to that. And so the more we can do to expose people to the fact that computer science is a really interesting potential career path, and getting some experience with it by offering, Google does a fair amount of work in K-12 education, particularly for under-resourced schools, so that we can expose more students to computer science. I think for many of us who have some expertise in this area, it's really useful to be able to then pass on your expertise to people who are sort of earlier in their career. I think, if you're a senior student at a university, find if there's a local high school where you can volunteer and mentor their robotics team, or mentor some sort of computer science interest group or something. Those are all great ways to get more people, exposed to computer science, and some of them may choose to pursue it, and that would be fantastic. I think this is super important because, as it is, computer science tends to be have many people who are very underrepresented, and what we want is all the people in the world who are building these really important systems and applications and software systems and services that affect billions of people, you want them to be representative of the people who are using them all over the world. And the more we can sort of attain that ideal of, the people who are building them are the people who are reflective of the people who are using them, the better it'll be.
Amazing. Thank you so much, Jessica, for your question. Cool. Well, we are just right on schedule here. I want to thank all the students that asked their questions. It takes a lot of bravery to be on here, speaking in front of hundreds to thousands of viewers. But I also want to thank both Jeff and Angelica for your insights, just being very thoughtful about your responses and being very reflective on your experiences, which I think are really going to hit home for the students. Giving them perspective on where you were when you were in their shoes and how you were thinking through things and what you were going through, to make it very easy for them to see a path to their next milestone. So thank you for that. It's been a pleasure getting to know you both. I just wanted to kind of give the audience like my two to three key takeaways from this talk. So the first thing that I learned from Angelica, one of the questions that you answered earlier was just about kind of perseverance, and just this idea that, it won't be easy at first. There are going to be challenges, but having, whether it's, peers or mentors kind of in your corner, supporting you along the way, that's what's going to keep you there and keep you motivated. But we can't really fully remove those challenging times, right? The second thing that Jeff, you alluded to a lot, was just learning from others. And I think, it's very easy to think that you have to either know everything, or that, we're in a competitive environment where collaboration doesn't make you smart or, things of that nature. So I think, my key takeaway is that learning from others is the key to success here. To actually seek out those opportunities to work with very smart people, knowing that you may not know as much as another person in the room or the whole room, but being able to be humble and open to learning and asking questions in that space is going to only make you better and help you further your career. And the last thing that I took away was you kind of both touched on the fact that, when you're looking for problems to solve and when you're trying to find these applications of AI that interest you, it's all about you and your interests, right? I think we were trying to get an answer out of you that it just wasn't realistic, right? It's all about the individual student's interest, the individual student's kind of passion for certain problems in the world, and kind of starting there. And then seeing how can they use their computer science background, how can they use AI and the technologies that are out there to address those problems. So I think that was very important. I think, that also applies to me currently where I'm at, and, just being super focused on the problems that are out there and then having everything else follow. So those are my key takeaways. I hope, the students had their own. But to all the students watching, I really hope that, you're not only inspired by this talk, but also just feel empowered to chart your path into computer science research. I truly can't wait to see what the future holds for the next, 1,000, 10,000, 100,000 computer science researchers that will stem from this conversation alone. So lastly, I just want to thank you, Jeff and Angelica, again for a great chat, and also want to mention the resources slide where you can learn more about Google research.
Yeah, and I'll just say thank you, Jehron, and thank you, Angelica, for this great event and participating. And thank you to everyone watching. We can't see you, but we hope you're out there. And I hope the times of COVID have not, we would all love to be together in the same room, but that this is actually in some ways better because more people can participate. And I hope you're all doing well and find some good tips from this.
Yes, thank you so much to everyone who joined. This was awesome. I feel like I learned some stuff as well. Thank you, Jehron, for being such a great moderator as well. Looking forward to seeing, as you mentioned, the next generation of great researchers and all the awesome things that you all are going to do.
Thank you. All right. Have a good one, everybody.